Can you see my screen?
Yes, I can.
Thank you. So good morning, good afternoon, and good evening, everyone who are joining us from different parts of the world. My name is Lakshmi Thapa, and I'm currently the president of ISPRS Student Consortium. I'd like to welcome all of you to this December webinar series that is being organized by ISPRS Student Consortium. And just to let you know, this is the last webinar series for this year, and we are very honored to have Dr. Jagannath Aryal for joining us during this webinar series. And let me start with a brief introduction about ISPRS SC and its activities. So before going through the introduction, I'd like to know a brief information about the guidelines. Please feel free to introduce yourself in the chat box and where you are from. And you can use Q&A session that is available at the bottom of your Zoom option to ask the question. And please try to be straightforward when you are asking the questions. And also, if lecturer asks you the questions, you can raise your hands even during the webinar session. And we will also email you the evaluation form after this webinar, and it will be nice to have your feedback that helps us to improve our future session. And talk about ISPRS SC. Well, this is the official representation of the youth to ISPRS, and it aims to link students, young researchers, and professionals worldwide who are interested in photogrammetry, remote sensing, and spatial information science. And it aims to promote their scientific and professional development. At the same time, it also advocates in imaging and geospatial science for informed, scientifically valid, and technologically sound observations of Earth conditions and trends that lead to improved and effective decision making. While mentioning about our current board of directors, you can see myself as the president. Then we have Nicholas Pusino as vice president from Australia, who is currently based in Australia. We have Sunny Kushwaha from India. Then we have Yogender Yadav, who is currently based in Italy. We have Miguel, who is currently based in Japan, and then Chukuma Okoli from Nigeria, if I'm right. And he has also joined us for this webinar series. You can see his name over there. And then talking about our various activities that we are doing. Newsletter publication is one of the major activities. And so far we have published 15 volumes of newsletters. And each volume includes four numbers that we publish every 3 months. And talking about recent issue, it is the ISPRS Congress issue, and you can even check these issues and access this freely from our website. And talking about our upcoming issues, we're trying to publish the next issue on application of social media data using geospatial analysis. But since we are in sort of transition period, we are trying to fix volunteers for designers, proofreading, so it is taking a bit of time, and we'd like to apologize for this. And talking about our next activity, it is about summer schools that we organize in collaborations with different organizations. This is also one of the prime activities that we are doing every year. We try to do at least 3 summer schools per year, but it can increase depending on the application requests that we receive. You can see we are regularly organizing one of the summer school in collaboration with IEEE GRSS Brazilian chapter. And also we're organizing regular summer school with ACRS. And at the same time, we are also organizing summer school with other organizations too. The next activity we organize is virtual room and ISPRS webinar series. Well, ISPRS webinar series, this particular series was started in 2018. And the first webinar series organized was on Google Earth Engine, followed by computer vision, machine learning, and others. And the concept of virtual room rise was initiated when there was COVID-19 happening, and it was difficult to meet each other physically. So our former team from ISPRS Student Consortium came up with the idea of virtual rooms to get connected with each other and the scientists, authors, students, and young professionals working from different parts of the world. And it was really perceived well by all the attendees. Uh, uh, and talking about a bit more on webinar, our main aim is to diversify the means of information and knowledge dissemination within ISPRS Student Consortium. And it is also a way of connecting ISPRS student members with a wider ISPRS community of scientists and professionals, and also to maximize the available expertise within ISPRS community by enhancing the learning experience of members of the ISPRSC. And yeah, the next talking about our next activity, where, well, whatever we are organizing virtually, we try to record all those videos, and we're also doing live streaming. And you can check our YouTube video too. All of our webinars are available on our YouTube channel, and we are having a really remarkable number of views on this. So far, the highly viewed webinar series is on the role of geosciences in achieving deforestation, free supply chains in Brazil, which has received the view of 3,000, followed by introduction to Google Earth Engine with R language, having viewers of 1.7K, and so on, as you can see on screen. And the very next activity that we have organized is GeoMixer by collaborating with different organizations like Ladies of Landsat, Sister of SARS, American Society for Photogrammetry and Remote Sensing Student Advisory Team, likewise IEEE GRSS Committee, Student Brand Chapter, ISPRS White Elephant Club, Asian Association of Remote Sensing. Like, we have collaborated with this organization to host GeoMixer, and this gives an opportunity to have an in-person talk with a real author or real scientist who are working in research related to photogrammetry and remote sensing. And we are also organizing GeoMixer related with particular program like ISPRS or ISPRS. With this, I'd like to let you know about Leadership and Service Mentorship Program that our former team started. And actually, the current board of members, I think most of us are the product of this Leadership and Service Mentorship Program. And we aim to start the same service mentorship program when we will be leaving tenureship and handing it to the new committee. It was really good to know and familiarize ourselves with the activity of how the international organization like ISPRS and Student Consortium functions globally. And talking about our membership, you can see the QR code available on the top right side. You can scan it and register yourself as an individual member of ISPRS Student Consortium. And the best part is it is free, and you can receive lots of facilities from our side, like joining ISPRS events, receiving information about various activities that we are doing. And also we have social media. We are active on Facebook, we are active on Twitter, we also have an Instagram account, and we keep updating our information on our website, that is sc.isprs.org. And at the same time, we keep all of our recorded activities in ISPRS Student Consortium channel. With this, I would like to invite our speaker for this December series, who is Dr. Jagannath Aryal. He has a PhD in optimization and system modeling, and he leads a research group on Earth observation and intelligent digital solutions to societal problems. He works in the Department of Infrastructure Engineering at the University of Melbourne, and his research interests are on optimal utilization of Earth observation information and geostatistics to develop new methods in object recognition. He's also the editorial board of the Journal of Spatial Science, Taylor and Francis, and Remote Sensing and DPI. He's the National Chair of Remote Sensing and Photogrammetry Commission of SSSI Australia. And we are really honored to have him for today's webinar series, despite the health difficulties that he's having. And talking about his title, I think it's better to hear more from him. and I'd like to give the floor to him now. Over to you, Dr. Jagannath Aryal, sir.
Sorry, Lakshmi, have we started recording?
Okay, let me start it now.
Thank you very much, Lakshmi, for your very nice introduction. It is my great pleasure, and I'm very much delighted to present this talk to the wider community of photogrammetry and remote sensing within the ISPRS student consortium. Today's talk, as Lakshmi mentioned, is Earth observation and digital transformation and outlook from infrastructure engineering. So I'll be focusing on that. And I'd like to welcome actually such a diverse group of people from 71 different countries, or 71 participants from different countries, and welcoming young PhD scholars and practitioners from different universities in different parts of the world. I can see that in the chat room, at least Philippines, Taiwan, India, and this shows the spectrum of the representation. And again, I'd like to thank you, the ISPRS student consortium team led by Lakshmi Thapa, who is based at University of Oxford, for this opportunity and the great work you are doing to transform our discipline knowledge and geomatics to every corner of the society. Well done. Thank you very much. And this is an acknowledgement to you, the ISPRS student consortium, and my employer, the University of Melbourne. As I said earlier, my name is Jagannath Aryal. I'm working at the University of Melbourne and leading the Earth Observation Research Group within the Digital Infrastructure Engineering Group. Let's start with something that is released this year by United Nations on our domain, on where or how or what science we do, with a focus on where science. Right. So this is to set the scene and for the importance of science of where, that is our discipline of geographic information science and remote sensing, how important it is to solve the many real-world societal problems. So with that, this talk is all about development of Earth observation data and platforms, practices, and their wider applications with a focus on digital infrastructure engineering. And I'll be talking on how digitalization revolutionized the way we live and design our cities, how techniques for accurate and precise data capture, object recognition, and interpretation are used in digital city design to integrate new information in cities' digital models. That will be covered within the setting of urban building footprints or urban systems, with examples from urban trees and their changes over time, and urban transportation and their simulation, how we can learn from the happenings out there. For that, what sort of ground-based and satellite-based data can be used? For example, ground-based sensor technology using Internet of Things and industrial Internet of Things as enablers. And on top of that, I will be capturing a little bit on digital protection. By doing all these digital activities, we need to be thinking as a futuristic concept of digital protection and knowledge transformation. And at the end, I will be providing some outlook on digitalization from the infrastructure engineering perspective, how we are designing our infrastructure in the digital environment. As a surveyor, from paper map to digital twin, how we are heading on for the efficient decision-making that will be captured. With that, I will be introducing you the University of Melbourne very briefly, and the faculty and our department, and the Earth observation progress in time and history, with a focus on geographic object recognition and contextual importance. What is the theory behind object recognition? When we have different platforms like camera, satellites, and other things, what is the fundamentals behind the object recognition? And what are the timeline and development of object recognition over time? That will be covered. And as an evolving method, and the recent, let's say in the last 5 years, how we are transitioning into deep learning methods for object recognition, and what are the current shortcomings, and what are the future trends, and where we will land, and how we are adopting those capabilities in deep learning that will be presented. And I will be showing some of the real world projects that I have worked and the ongoing one, and some of my group student or some of the student project like PhD projects from my group will be shown very briefly. And I will be looking the deep learning advancement from critical lens. Hopefully that will be useful for many PhD students and practitioners. And I will be introducing the academic team in geomatics discipline, which we recently changed to digital infrastructure engineering. So that will help you to reach out to us and spread the word on who we are, what we are doing. So University of Melbourne is one of the world's, the latest is 30 finest universities, let's say 50 different ranking, but absolutely number one in Australia. And we have 160 years of academic leadership. It was established in 1853. And within the university, we are in Faculty of Engineering and Information Technology, where we have 400 plus PhD qualified researchers and teachers, 300 students, 700 masters, and 900 graduate research. And we have dual accreditation, like Engineers Australia and EURES from Europe, meaning that students who are getting degree from University of Melbourne can work across Australia and Europe with this accreditation system. And we have cutting-edge interdisciplinary research and work with a range of partners from academia, government, and industry. And this is the infrastructure engineering department where I work, and we have a focus on different groups. And basically, you can see civil engineering, environmental engineering, and geomatics are the core within the infrastructure engineering, and we have different discipline groups within those core three leading groups. And this is some statistics about our demography of academic and student numbers. So what we do in geomatics or digital infrastructure engineering, basically we focus on measuring, modeling, managing, predicting, and visualizing our world from the lens of location intelligence. We focus on digital infrastructure, land and property management, 3D cadastral and urban land administration systems, high-definition real-time maps, digital twin. You heard about digital twin, you read about digital twin. This is all about the physical world to replicate into digital environment. And we are doing science behind digital twin, not only visualization, like simulation and beyond simulation, how we can use the granularity, how we can use the resolution, and how we can use the frequency, intensity of the real world features that we capture in the digital environment. And we do analytical and visual decision supported services. For example, automated data analytics for dashboards, forecasting, sustainability, resilience, and disaster management. And we prepare business decisions and urban analytics, all foundational on location intelligence, Earth observation, and ground-based sensor analytics. We focus on autonomous systems like intelligent driving, drones and robots, smart environments, and digital twins within those ecosystems. Bit of focus here, measurement science and 3D modeling, we do spatial data infrastructure and land administration, we do, and spatial information science, we do, where GIS, spatial cognition, spatial data analytics, by using different format of data sets like raster, vector, and the combined. And we have a research center within the group where it focuses on data infrastructure and their visualization and location intelligence. It's called Center for Spatial Data Infrastructure and Land Administration. And I'd like to introduce the Master of Digital Infrastructure Engineering, where you see we are now heading into as a profession in the digital infrastructure. And from the engineering lens, what we do first we do in the digital environment, and then we calibrate, we validate in the real world, and vice versa. That's why digital is so important. And from this year, early next year, 2023, we started a new course at the University of Melbourne, which is a continuation of surveying degree. It is basically traditional surveying degree, but with the new name. So this is, I'm the course coordinator of this, and I think we are pioneering in Australia and in the world this type of new degree, where we are marrying between engineering and IT, and the information technology subjects are there. So with that, engineering meets IT, where the student will acquire skills in sensing, managing, analyzing, and communicating data, monitoring our environments, and using digital technology to improve processes. And they specialize in different specialization, like 10 or so. So from this, you can see we are preserving the core of surveying, and we are providing them the IT skills, and we are letting them as a person where they want to develop by doing specialization. For example, someone would like to specialize on land, they can do. Someone wants to specialize on construction, they can do. So this is, you can see from where in the developing world the conflicts start is from land ownership. And if you look in the developed world, the conflict or debate starts in constructions, right? So these are the core surveyors can contribute. That's why we see this degree as a spectrum where we are handling the challenges of real world that we are facing in the present day. So with that, we are keeping the core, we are providing the IT skills, and we are letting students to explore their passion by specializing. What it does in practice is we assess the impact of a wind farm, for example, on nature and people, and how this is balanced by the benefits at particular locations and with particular designs. We create digital construction workflows, and we help emergency teams as well as evacuees in disaster management. In practice, we do managing public transport using remote sensing sensor networks for urban green management in smart cities. And we help autonomous vehicles by providing the information where to go with high definition maps. So this is I'd like to introduce as a commission chair of National Chair of Photogrammetry and Remote Sensing Commission of Surveying and Spatial Sciences Institute of Australia. This is relevant to ISPRS, where I'm leading this, and some of the members from this committee are ISPRS key members. So with that background and all the information on new digital infrastructure engineering degree, let's now focus on the progress in time and history from object recognition lens within the Earth observation umbrella. So when we talk about object recognition, we need to be focusing on different kind of fundamental laws, like law of simplicity. If you look into these circles of the Olympic symbol, we perceive as 5 circles and not as 9 different shapes. However, we tend to see as simple as possible law of simplicity. But if you look in detail, you can see 9 shapes. But we don't want to see 9 shapes here. We want to see the 5 circles, which is law of simplicity. And the similarity, as a human being, what we do is we want to group, or we tend to group the similar things. If you see here, all the rows have a similar structure, but we visualize columns of squares and circles. So that is grouping of similar objects, law of similarity. Likewise, law of familiarity will work for us as a human being in our perception. The patterns marked in red are perceived as faces. Grouping of familiar objects is law of familiarity, and these patterns marked in red are not the faces, they are the natural objects. And the patterns, when you look into different shape, size, color, texture, form, and contextual knowledge, what we do is, whether it is couch or carpet or zebra, we recognize the pattern, and it depends on the context. We easily say this is couch, we easily say this is carpet, we easily say this is zebra. So what form that knowledge is? That knowledge is color, form, and arrangement. For example, as a human being, we can do that. So with that, the point of showing that is how we want to automate the object recognition, capturing those fundamental laws, and how we want to develop algorithms so that we can mimic our perception into automated way. For that, in the object recognition field, colleagues like Thomas Blaske and myself, we prepared or published papers where you can see the relationship of object in horizontal level as well as in vertical level. For example, when you see in the left picture with the white arrow, that is neighborhood relationship. What is the relationship of one neighbor, that is one pixel, to the other pixel? Or if you look into polygon level, what is the neighborhood relationship of one polygon, let's say center polygon here, to the neighboring polygon? If you look into black, or the hierarchical relationship, where you see the hierarchy in a vertical sense, or the relationship in vertical, which is the object and super object as well as sub object. If you look into level 0 in the left, and level -1 and level +1, that means object level as well as +1 is super object level and -1 is sub object level. And if you go down the track, then you go to the pixel level. That way, how we recognize the object in high level spatial aggregation, from pixels to objects to sub-objects to objects to super object, right? Or parent-child relation that we can see. And in the right, you can see a polygon where a single polygon is there in level 1. In level 2, you can see multiple polygons. And in level 3, these polygons are increased within those polygons. And top right, you can see that how we are visualizing from pixel to entire object. So this geographic object recognition contextual importance is we can frame into different framework. Like, for example, we have natural earth here, and we have digital earth. And we do the data labeling, we do the training, and we develop different frameworks within the help of a GPU, and we develop the models. And later we train the deep learning model and then extract the precise and accurate information. Right. Sorry. So with this, I'd like to show here the relationship of neighboring objects, sub-objects, and super-object in the object hierarchy. And just to show you here how these are formed. For example, in the left, you can see the links from pixel level to entire image, entire satellite image in different level of hierarchy. The challenge is automation, challenge is how precise, how accurate we want to extract these objects per fit for a proposed thing. For example, there is no one single rule to extract objects. Sometimes we need a single tree for our analysis. Sometimes we need a group of trees, sometimes we need forest, and sometimes we need a big, large Amazon forest, let's say. So those sort of things are a scale issue that we try to address here by extracting, or let's say delineating, or by putting, let's say, the frontiers, the boundaries, where to put the boundaries is a challenge, right? We are so unique as a human being. Our eyes are so powerful. We can put the boundaries, but that's not the solution. The solution is how to automate that perception, how to automate our visualization is a challenge. And we are progressing on that. That's not a rocket science. We are doing that, but how to do in a way so that society can benefit, so that we can contribute in the society. Let's say urban planners, let's say sustainability people or sustainable development goal practitioners, let's say the people who are after food, after clothes, and those sort of things, how we can help and make no one left behind. So with that, objection in spatial resolution, you can see here, just to highlight, all of you know, in the left, we have different objects. And with the different development of Earth observation data sets of different resolutions, either we can capture them in 1 pixel in 30 meter, 2, we have to merge different pixels to characterize them to 0.5 meter. So with that, the objects, ontologies, and semantics come into play. And as I said before, the whole goal here is automation and extraction of precise and accurate objects. For that, this is a picture I took from published work from Blaskey et al. 2014, where how we recognize the object and what are the elements or what are the ingredients associated with those object recognition and object extraction. You can start from image object hierarchy, as I presented before, from pixels to objects to super objects, and then semantics will play. I said automation, but always the expert knowledge is important. Domain expert knowledge is key. In a different parts or different steps, we need to consult the expert who can rectify what computer is doing, what algorithm is doing. For that, we can develop that explicitly defining ontology, which is a basis for semantics, and we develop the rule set that creates the semantics for image object hierarchy, which is fit for a proposed thing. Depending on what is the application we are after, we will develop the semantics or the rule sets. So in the object recognition concept, we do in an iterative way where expert knowledge will come into play, and we can start from original image. We do the multiple segmentation, multiple image object representation. We do optimization, selection, and then it cycles from 1 to n, where we classify, pre-classify, and validate. The whole idea here is to how to label accurately. First, how to extract accurately, and then label or classify the targeted class. And one example here, feature extraction from point clouds. So in the right, you can see what is existed in the physical world, and that can be extracted as feature, first point, and then line. And this is just to show you, everyone knows this, and how we are traveling from 1960s onwards in the Earth observation era with different types of Earth observation that are available from 60s to 2020. And if you look, and what are the algorithms we are using, and what are the spatial resolution we are capturing in, and what are the application areas we are using with these all Earth observation images. And we have different computational capabilities from 2010 onwards with the GoogleNet, AlexNet, BGG, GAN, and RCCN. These are giving us more computational opportunities and to extract the information and to apply for the societal use. And what are the technology? What are the information technology infrastructure? For example, let's say we have ground-based and we have satellite-based technology. And what we want to extract the object that turn into information. We want to turn that information into knowledge and at the end to wisdom. How we do that? We can control the image objects using spatial data infrastructures. What does that mean is, let's say we have polygon layers from an SDI or spatial data infrastructure like digital cadastre, landscape units, agricultural field boundaries, or point clouds, etc. This can be used to constrain segmentation results as predefined boundaries so that it will not cross. So we manage the physical world within the digital environment. We can integrate the object information incorporating Earth observation and SDI, which is possible. That I will show you a couple of past examples and the present works. So before that, I'd like to brainstorm for all of you and myself, what are the key scientific issues in geometric engineering at present? And it will change over time. For example, if you look in a very broader sense, we have spatial, temporal, and spatio-temporal environmental processes out there. And how we accurately understand them and how we model them is a challenge, right, or issue as a research. And we have dependencies associated with these processes. Obviously, we have different variables and they are dependent on each other. How we understand and characterize those variables and then understand their sensitivity in the process. For example, if there is a bushfire, what are the variables that are, more sensitive and how they are dependent on each other? Let's say pressure, let's say temperature, let's say wind direction, let's say some other factors like vegetation. So these are dependent and these are sensitive to bushfire. And how we do that, what I said just now, how we do the modeling of that and visualization of those sensitivities, that will help the decision maker. That's one environmental process. I'm giving an example. Likewise, sea level rise. Likewise, let's say earthquake. Likewise, let's say earthquake-induced landslides, or let's say the informal urban settlement or displacement due to all these disasters for the people who has to leave their original place and migrate to somewhere else because of those disasters. And we can model and visualize of such dependencies to infer policies and decision-making of different processes. We can have optimal automation pipeline, data and information for application projects. And we can have translational research to make impact to lives and making change to status quo. First, we have to think about how we can change the people's lives from status quo. So these looks generic, but these are the fundamental things as issue or scientific issues in geometric engineering, where we use Earth observation and geographic information science to inform the decision maker, right? So with that, let's have a look at some real world projects, as I said, past and ongoing. So in this image overlaid with cadastral boundary, you can see here where the cadastral boundary is helping us to analyze the vegetation within those boundaries. And then we can derive the relationship between built up area and the relationship between green infrastructure, for example. Likewise, we can map the garden complexity. We do have garden in our backyard, we are in our front yard. But what is the importance of those gardens and how we can map them? We can fuse different data sets like multispectral and panchromatic and get the more accurate and more visual result, not compromising with resolution, but enhancing the spectral resolution and enhancing the spatial resolution. And we can map them based on the density of the composition of trees within them by looking into the reflection. Without visiting physically the places, we can do remotely. Likewise, we can depict the urban tree change within the urban setting and relate that to different processes like real estate, where there is more trees, it's likely that the property will get more price. Likewise, the shadow analysis we can do, visual analysis we can do, all these GIS capabilities we can link to real world applications. And some of the examples on bushfire that we published earlier, if you have a moment, please have a read on these, like big Earth observation data integration using deep learning, and we published in Open Science Journal from the Royal Society of London. Quantifying bushfire mapping uncertainty is another project that we published in 2016 in ITC in Enschede, where there was a conference. And here we took an example of a real world bushfire that happened in Tasmania, where I was working before, and then we quantified the uncertainty. And some of the, as I said before, earthquake-induced landslides. This is from Nepal, and one of my PhD students was working on this, which is UAV-based slope failure detection mapping. That was using unmanned aerial vehicle used to obtain remote sensing imagery from study site and the field photographs of slope failures observed during a field visit to the Himalayas in April 2019. There was a big earthquake in 2015 in Nepal, and after that, people were displaced in many places. They were displaced from and relocated into new areas. And this is published in 2019. And what we are focusing at the moment is an Earth observation for sustainable cities with the intelligent data analytics approach to contribute on sustainable urban infrastructure for the growing population by using different means. And our approach to urban feature extraction is basically, as I explained before, we address different problems like domain shift problem using transfer learning to build a scalable deep learning methods, and increase accuracy and precision using multi-scale feature information, train on a smaller yet robust data sets, prepare using APIs for automation, and increase usability by preparing end-to-end method based on lightweight deep learning networks, and reduce computational requirements by reducing network parameters. That's how we are focusing in urban feature extraction at the moment, and these are the steps we follow from 1 to 8. Like if you look anti-clockwise, we have Earth observation, very high resolution imagery, we do the labels, we design the deep learning methods, and the framework and hyperparameters we design and implement, and we train the network, and we make the domain adaptation, and we do the post-processing. That way, we can achieve the accurate and precise urban features extracted and generated into information. And going back as a surveying, my training, and then I remember my days when I was doing my surveying training, preparing contour map by hand, 1 to 25,000 topographic map, 1 to 50,000 topographic map, cadastral map, etc. by hand. And I reflect that in a journey from paper map to digital twin. Now I'm doing digital twin, right? I'll show you that. From paper to digital and to 3D high definition, to SD Live, to indoor mapping, and at the end to digital twin. So that what I would like to show you a couple of examples how we are doing this digital twin by integrating the real world data sets in real time and then making visualization and doing a science as well, not only visualization. So we have specially enabled digital twins. There are policies and standards built, and we are working based on those. And what are the system components that we use for that is different technical solutions and different softwares. I will not be reading all of them. And what is the urban digital twin? Is basically you heard about this and you saw different definitions, but what I would like to say is it is replica of physical world in digital environment. Some of the examples I would like to show here: live data integration, analysis, and visualization. So you see how we can visualize those live data from the live traffic here map and live satellite image, Bureau of Meteorology, live CCTV, big roads, and live tram, which is PTB. So you can see in here differently, and I will play that, and you can see all that. And you can see in the Bureau of Meteorology how the weather pattern is changing. with live satellite image. That can be captured and for a high-level decision making, and where to support and where to act as a act of information we can derive from this. Right. The other project we have done is University of Melbourne Space Management, where you can see different infrastructures are managed based on their location and their capabilities to host people and things. And you can see how we can slice the buildings and then develop information out of those buildings and use those information for decision making. And you can choose different, you can select the building and you can choose all that. The other example is, as I said, Internet of Things and sensor network like occupancy analysis. We can do for each of the building, what is the energy? For example, you see here in the left, the building energy index, we calculated building maximum shadow impact and occupancy model, and all these is presented here. Right, so that shows the building's capability in holding energy and releasing energy, I mean, based on our index. Right. So another one is United Nations Sustainable Development Goal in the university environment for those buildings. So we try to develop index for SDGs and put different indexes there. I mean, out of 17 goals, we provided there. Right, so I will be a little quick in the interest of time. So some of the PhD projects as well, I'd like to show you the spectrum of projects that we are working on here. So fusion of multi-sensor Earth observation data in identification, mapping, monitoring, and modeling of croplands, where you can see how agricultural fields or the object are extracted, and then why we need to do with the new evolving approach, and what are the shortcomings of traditional approach of field boundary delineation. And this is my student Sumesh Kechi, who is working on this problem and progressing very well. The other same project here, and he's using semantic segmentation with multitask learning. And at the end, he will be producing uncertainty quantification, delineated field boundaries, and accuracy assessment. And the other student, Bipul Nepane, is working on Earth observation for sustainable cities and intelligent data analytics approach, where he's working on building footprint data using Microsoft data and Geoscape local data, and then applying the deep learning architectures to improve the building footprint extraction that will help for decision processes like energy and sustainable planning. And the other student is working on identifying dynamics of urban sprawl or governance of urban sprawl, a means for achieving Sustainable Development Goal 11, and where we are looking into integrated approach to urban sprawl management. And this student is Kriti. And the other student is working on remote sensing of bushfire severity, where he's working basically with the meteorological data and topographic data, fusion of them. And the outcome would be the severity map, where the practitioners can benefit from this. And this is Saroj, who is working on this. And the other project I'm looking is with the PhD student, Ricardo, where you can see spatial dynamics of the informal urban growth in disaster-prone cities, impact on resilience and sustainability practices. And this is before the disaster, what is there in the city, and after the disaster, how people are displaced. And that is mapped and related to the policy and practices in different parts of the world. So I'll be quick on this. And just to wrap up, as evolving method of feature extraction or object extraction, we are using deep learning, but we already seen this method and the improvement on it by addressing the problems or the limitations. So some of the limitations I would like to highlight here, which is like scale-up limitation and accuracy and precision. So boundary pixel classification is a problem. Structural stereotype results in over and under segmentation, but we know how to address them, all that. So this is another limitation. I just would like to read that. Requirement of large level training data sets we need, and lack of usability and increased computational expense is there. So to address those limitations, we have current trends that's going on, like scaling up, accuracy and precision, data sets, availability, usability, and the computational capabilities, advanced computational capabilities. And these trends are helping to address those problems. In the future, definitely, we will be looking into scaling up, like this problem is always there, addressing domain safety using GANs or generative adversarial networks using transfer learning, and accuracy and precision by multimodal and multi-scale learning, language models to vision transformers. The practice is already started, but it is in very early stage. The other bit is robust datasets, synthetic datasets from GANs. And we can use transfer learning to increase efficiency using small datasets. For example, how the universal knowledge can be derived using small datasets and large datasets within the process of transfer learning. This will help to scale up and to increase efficiency using small datasets. And the usability can be addressed with YOLO and UNet 3+, for example, wrapped in PyTorch. And no-code AI is another one, drag and drop training data, generate prediction report, asking questions in plain English, and complement Internet of Things with artificial intelligence, like TinyML is lightweight machine learning models for industrial applications. And computational capabilities will be there. I mean, it is not in practice yet, but in 3-4 years, within 1-2 years or 3-4 years, who knows, quantum computing will lead us and will be available for us to run these billions parameters, 100 billion network parameters within the deep learning. So with all that, what I would like to wrap up is the case study examples showcase accurate and precise objects are integral to the digital models. The digital models on urban setting, as I showed, building footprint and their extraction, urban trees and their changes over time, urban transportation and their simulation, which I showed you, and the contributions of Internet of Things, including industrial IoT, will provide the digital capabilities for infrastructure assessments and city design. The importance of digital protection and knowledge transformation capture highlight the future of the cities and our lives. A complete digitalization of infrastructure is foundational to the sustainable city of future. With that, I'd like to wrap up with one small video again from the recent conference. With that, I'd like to introduce the academic team, Geomatics, our digital infrastructure discipline team here in Melbourne. And I'm focusing on remote sensing and disaster response. And my other colleagues are focusing on Amir, satellite positioning, Koros, laser scanning, Abbas, land administration, Dawood, spatial visualization, Martin, spatial databases, Stefan, intelligent mobility, climate neutral mobility. And we have other academics from all fields of engineering, computing, and information systems that are collaborating on different projects to us. So we have a suite of people with full knowledge and experience. With that, I'd like to thank you, and I stop here. Thank you very much.
Thank you so much, Dr. Jagannath Arial, sir. It was very nice presentation at your end, discussing about the digital transformation and various technologies that we can use in adapting and in adapting and accepting these digital technologies for urban mobilizations and other applications. And one quote that I remember from your presentation right now is everything that happens somewhere. Indeed, I think geography, geopositioning, geolocation, it is really powerful because of the locational identity that it has. And with the rising development and advancement in machine learning, deep learning technologies, and computational advancements, we are having lots of digital transformations every year, every month, which is really, really nice. So thank you very much for insights on various technologies that you are using on your research, and also letting us know about courses that are running on in your university, and also various research that your students are doing there. So any of the attendees here, if they are interested in joining, I think in joining the courses on digital transformation or something, this could be a really nice opportunity to contact with Dr. Ariel. And starting with the question, I think I can see some of the questions on Q&A and also on chat box. Let's start with the question on chat box. One of the questions says that it's from Chucks. He says, "Dear Dr. Ariel, in your projects on fusion of multi-sensor Earth observation data imagery, what pre-processing steps are used to ensure precise co-registration and correlation of the multi-scale and multi-sensor imagery datasets?"
Thank you very much. So this is definitely a very good question. And then when we have multi-sensor Earth observation datasets or images, we are aiming, like, let's say you have, just start with a simple example of Iconus multispectral 4-meter spatial resolution, and you have Iconus panchromatic 1-meter spatial resolution. Now you want to fuse that, what I showed in the example, and then you want to create a multispectral image with 1-meter spatial resolution. So it is possible to do that. So for that, the question is how to ensure the precise co-registration and correlation of the multi-scale and multi-sensor imagery. For that, you need to check with the ground control points. You can check different parts of the images from corners to centers in diagonally or whatever way. Let's say you have at least 3 to 4, and then you can have those errors. With those errors, if these are within the limit, then you're happy with the fused product, right? That's one example. So we have other examples that we can use for the fusion. Nowadays, we have automatic fusion algorithms in the software environment, as well as we can write the software ourselves, I mean the code ourselves, to do the fusion. The aim is having multispectral with high spatial resolution within that example. Likewise, if you are looking for point cloud, so you can do that, right? Again, what you will be checking is you will be checking the accuracy of the ground control points or accuracy of the checkpoints. So that you need to be developing. Hope that answers your question.
Thank you. And the next question from Q&A says, it's from Nicholas, and it says, for digital twins research, a lot of special data from different sensors are needed at multiple scales. It seems easier to develop such approaches on rich cities rather than less developed cities or countries, where it would be more needed. How do you think remote sensing and or what sensors can help in apply these research practices in less wealthy countries?
That's a very good question. Again, it captures multiple dimensions. Thank you for that. Not only technical, you're asking here economic thing, which is very nice and very practical. I appreciate that. And by answering your question here, I agree. In the less developed cities or countries, it could be more needed. In my opinion, how we can leverage the Earth observation capability or sensor capability to less wealthy countries is selecting the sites that are really needed, and then, running like drone or deploying IoT sensors in a small scale, right? So it is difficult to deploy in a large geographical extent, but depending on the priority, if we can, discussing with local communities and defining the priority and assessing the priority and deploying those technology like drones or IoT is the solution I can see, in my opinion.
Thank you so much. Yeah, I also think like drone technology can substitute in acquiring like updated information, as we may not have good spatial resolution from satellite data, or we may not be, or the developing countries may not be able to acquire high resolution satellite data, but drones can be a substitute for sure. And the next
for the ground-based Internet of Things, IoT sensors.
Yeah, I think IoT sensor offers more cheaper solutions and economical solutions even than drone, I think.
Yeah, that's right.
And the next question again from Nicholas says, what sensors or platform that is not, okay, it's somehow related to the same one, but I'd like to mention it here. What sensor or platform that is not available or affordable today? He's saying, let's make a wish you'd love to use, or how that would help your research. So he's asking what sensor or platform that is not available or affordable today, but you'd love to use, and how that would help your research.
That's right. This is basically what you can think of is, different sensors that are integrated into drones with the different frequency domain. And in the IoT space, in the ground-based sensor space, you can think of the environmental process and the phenomena. For example, if there is a landslide, what sort of attribute you want to capture? If there is, let's say, earthquake, what sort of attribute you want to capture? If you can make an architecture of those attributes and design the sensors. And we have designing sensors companies or people, let's say sensor designers, we are working with them. So if we provide those attributes of wish list, and they will come as, yes, we can integrate your wish list of attributes in our sensors. Let's say they are capable to do that. And then we can deploy those IoT, Internet of Things sensors, and capture all those attributes in our desktop environment from the field. That, I think, the future is that.
Thank you so much. And the next question from Chucks says, with regard to object-based image analysis presentation, I noticed that the smallest unit in the hierarchical relationships shown was the pixel level. Is OVIA capable of sub-pixel feature detection and analysis?
Yes, it is. How you define the object is your interest. Depending on your interest and the phenomena you are taking into account for your research, you can define the objects from sub-pixel level, and you can define the entity on that level and aggregate them to object or pixel or object, super object level in a parent-child hierarchy. Yes, it is possible.
Thank you so much. So we are also running out of time, but one last question that I'd like to ask is, sure. You are mentioning, and also for digital transformation, like lots of adaptation, lots of changes in technologies are coming. So how computationally efficient or how economical they are in terms of computations, or while adopting machine learning, GPU, or those technologies, do you think?
Yeah, that's a very good question. If you look back in 30 years, 40 years back and now, the computer development, people were using, the computers of, you can't imagine now, right? So nowadays we are using very high processing GPUs, and in the future, as I said, quantum computing is in the horizon. So I can be very optimistic. And at present, we can think of how this is expensive and not reachable to many people. But I think in the future, we will have cheaper computational and more available computational resources. At the moment, you're right, it is not accessible to everyone, but in the future, it will change. Let's be optimistic.
Thank you so much. So it's the very last question that I'm going to ask, sorry, because more questions are coming. The question says, I'm also curious about the, okay, we have 2 more questions now. I'm also curious about the performance of OVIA versus traditional pixel-based classification methods. Please, how does it compare?
Right. So this is, again, the architecture, how you define. For example, you define the classification scheme of, let's say, vegetation classes, and you want to classify the image, let's say pixel-based for the vegetation classes in the urban environment. And as a second option, you have object-based classification in the same environment. And then when you compare the accuracy, and it will definitely be object-based, will be more accurate, given it will capture the context, it will capture the neighborhood relationship, it will capture the hierarchical relationship, right? In the pixel-based, you will define based on the reflectance only, but more contextual, more hierarchy, more relationship, what is happening out there in the real world, like dependencies. These all will be captured to some extent, not perfectly everything, right? So in your rule set or in your sample selection, whatever way you do, that's why we prefer object-based, depending on your application.
Thank you. So, Nick, I'm not taking your question as I think I took many of yours. So I'm taking the question from Juan Pedro. He says, I have found very interesting use of 4D viewers, geolocation plus time, to visualize information at office and building level. Is this viewer online? Could be possible provide the URL. Do you have a course for the generation of this type of viewers?
Yes, thank you for this. And then you can contact me by email. And we do have course like visualization of information, how we visualize the information using different tools and different techniques. So that might solve your query. So please be in touch.
Thank you so much. So considering the time, I would like to stop now asking the questions. So as Dr. Ariel just said, if you have more questions, you can contact him through email. And thank you very much, Dr. Ariel, for your time. And it was really nice to have you here. It was really interactive, and your presentation was amazing. So we loved it, and we will try to upload this YouTube video by the this video on YouTube by this weekend, and we'll also let you know, and also to all of our participants, we will let you know once we upload this video through our social media. Thank you very much, everyone, for your time. And with this, as we publicized in our social media, I would like to mention a few things about the volunteer call we have made. I just have 2 slides that I would like to present it in front of everyone. And if you guys have any questions, you can ask us, and I'll be happy to answer those questions. And let me share my screen to you.
Thank you. Thank you very much. And actually delighted to interact with you, Lakshmi, and the team. And thank you for the opportunity. And I will be in touch, and please be in touch, all of you who are online. And I'll be more than happy to work in collaboration with you all. And with that, I will stop my sharing here. Thank you.
Thank you so much. Okay, I hope you're seeing my presentation slide.
Yes.
Yep.
Yes, so sorry. So we made a call, I think on 25th November, saying that we need volunteers for a design team and proofreading team. So basically, we want the 4 person joining us for the design team, who will be responsible for the creation of design-related content for ISPRS SC. which includes our newsletter called Spectrum. And at the same time, what we are doing is every time we organize any kind of event, we try to create posters as a template. So the design team may need to design our publicity and promotional content, and also different banners and all other digital media for promoting our events on different social media. So we would love to have you as a volunteer if you think you have a good design principle and you are adept in publishing, and you are aware of how to use Adobe InDesign, Adobe Photoshop, or other design related software. And at the same time, we'd love to have a team member who knows how to communicate well and who knows how to collaborate with the team. And also for the proofreading team, we are in need of 2 persons joining us for proofreading. And if you think you have a good command of the English language, and if you are detail oriented, creative, and has excellent time management skill, and also, as I mentioned previously, if you think you are a good team player and you would love to do a collaboration with the team members, please feel free to join us. Our extended deadline is December 10. And you just actually we try to make this application process as simple as possible, as we understand as a student or as a young professionals, you may not have enough time to go through an entire application process. So you just need to provide us a 2-page CV and a motivational letter specifying which position you are applying for and what motivates you to apply for this position. So feel free to email us by 10th December, and we'll try to get back to you as early as possible. Yeah, that's all from my side. So if any of you have any questions related to volunteer call, you can write or you can raise your hand. Whatever platform do you feel comfortable. If you don't have any questions, thank you again, and we can end this webinar series.
Thank you very much. Bye now.
Thank you so much. Okay, thank you everyone for your valuable time.